right, everyone. So today we're going to talk about the quadratic formula. And so this is kind of a culmination of solving quadratics. And this is probably the most common and foolproof method of solving quadratics, generally. So, all right. So some of the other methods are good, like factoring. If an equation is set up conveniently for factoring, or if you have your graphing calculator, graphing is a good way to go as well. But if you just want one way that does it all, and that's probably more efficient than completing the square, a little more straightforward than completing the square, then the quadratic formula is the way to go. So this is the quadratic formula here, and this is something that I bet you've seen before. And there's different songs and things to remember the quadratic formula. We might do some of that or explore some of those in class. But it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so notice the all over. So the negative b here is on top with all this other stuff, right? So sometimes people kind of forget and they kind of keep b out by itself. So make sure that you have that whole thing in the numerator and the whole value divided by 2a. Okay. Then we're going to talk about the discriminant, which, if you notice, is what's underneath the square root there. And the discriminant tells you a lot about the solutions of a quadratic. It tells you how many you have, and it tells you sometimes, or not sometimes, but it tells you all the time whether your roots are going to be rational or irrational. Okay. All right. So we'll talk about that as we go. Now, the quadratic formula, this can be derived by using the completing the square method. So even though this is going to kind of supplant the completing the square method as far as the method that we can use all the time, it's actually generated by the completing the square method. So anyway, so that's where it comes from. So let's explore here. So if we have a quadratic, and this is a general quadratic, so I'm keeping it in terms of a general form where a, b, and c are variables, but those represent integer values, or actually they could represent any real number, right? And so if I were to solve this by using the completing the square method, what I would do first is subtract c from both sides. All right, so then we would get ax squared plus bx. I'm going to leave room to complete the square here, just like we did. And then move this just a little bit. And then equals negative c, right? Okay. So then the next thing we would do is we'd complete the square, right? So I put plus, and actually before we do that, I'm going to divide everything by a. So I forgot here we have a coefficient in front of x squared. So, all right, so I'm going to divide everything by a. So what I'll get is x squared plus bax. And then now I'm going to leave room to complete the square, equals negative c over a. Okay, so remember that what I want to put in here is I want to take half of that and square it, right? So I want to take half of this term here in the middle and square it. So it's going to be b over a, and I'm going to take half of that, so I'm going to divide by 2, which is the same as multiplying by half, right? Because remember, we flip that guy and multiply. And so it's going to be the numerator multiplied by the reciprocal of the denominator, right? So that's what we get there. And so we end up with b times 1 is b, and then a times 2 is 2a, right? And you might recognize that as similar to the vertex formula, right? How we find h. The main difference is it's positive instead of negative, but that's part of where it comes from. All right, so now I want to square this, right? So I'm going to take this and I'm going to square it. So it's going to be b over 2a squared. So it'll be b squared. And then on the bottom, 2 squared is 4 and a squared is a squared. So that's what I'm going to plug in here, b squared over 4a squared. And I just did that by taking the middle term, dividing it by 2, and squaring it, right? Which is what we usually do to complete the square. All right, so now I want to factor it. So now that I have this, I'm going to put it into this format, right? So remember that what we do is we put x here. I'm going to put the plus here. And then remember what we put here is p, and I didn't label this, but this is p, right? P equals this right here. So I'm going to put b over 2a here. All right, and then equals, and then I'm gonna put the b squared first, minus c over a. Okay. And then what I want to do is I want to simplify this. So I want to get these to have, or c over a squared. Don't forget the squared here. So what I want to do is I want to get a common denominator here so that we can combine these together. So what I'm going to do is I'm going to multiply by, we'll just take this off to the side. So I'm going to do b squared minus 4a squared, or b squared over 4a squared minus c over a. So what I want to do is multiply by 4a on top and bottom. And what that gives me is b squared over 4a squared minus 4ac times 4a squared, right? So 4ac, and then this comes to 4a squared. So now I can combine those into one fraction, right? So I can make this b squared minus 4ac all over 4a squared. All right. Now this is kind of the reason for why the vertex is negative b over 2a, because that's what makes this equal 0, right? If x is negative b over 2a. And so anyway, that kind of gives you where that formula comes from, or at least one way to think of it. All right, so what I'm going to do now is I'm going to take the square root of both sides, right? And then I put a plus or minus here, square root property. Square root cancels out a square. So we end up with x plus b over 2a equals plus or minus, and then we get all this stuff right here, right? Now this top is not a perfect square, so I can't do anything with it, but the bottom is a perfect square. So I'm going to leave the top as b squared minus 4ac all underneath the square root, but the bottom, the square root of 4 is 2, and the square root of a squared is a. So if I take the square root of the denominator, I just get 2a, and it's not in, so it doesn't, it comes out of the radical, right? So we don't have the root going in the bottom anymore, just on top. Okay, so we simplified the radical in the bottom. All right, so now I'm going to move this to the other side, and I'll get x by itself. So I'm going to subtract b over 2a from both sides. All right, and notice how these already have a common denominator, right? So I can actually combine these into one fraction. So it's going to be x equals, and I'm going to put negative b in front, so it'll be negative b plus or minus b squared minus 4ac all over 2a, right? So I combine this in the numerator over that common denominator. And that's our quadratic formula. So that's where it comes from, is from completing the square. All right, and we'll use this a lot in the upcoming examples.